Hi guys, just want to give you a little heads up, a little information, a little review of the battery assignment that Eric and I developed. And I just wanted to show you a little bit about what happened here. I've done this experiment now with my spring class and my summer one class. The spring class was more of a learning curve for me. The summer one class went a lot better. So let me open up the presentation and we'll go from the beginning. And I'll put myself down here for the time being. And just looking at the battery presentation. And I should have put myself up here and shrunk myself in a little bit more. Okay, this is our assignment. This is our battery. We have built a 4-cell battery, for 1, 2, 3, 4 cells. Each cell has a zinc and a copper plate. Zinc, copper, zinc, copper, zinc, copper. And they are connected to a battery switch. And they also connect to a load switch, and the load switch is connected to an LED which we can turn on and off. We have test point A, test point B, and test point G. With the battery switch in the off position, each cell is individual, so I can measure individual cell voltages. If I close the battery switch, I connect each cell in series, and I come up with a total voltage for all four of the cells. And I can measure it between A and G, measure the voltage between A and G. If I close the load switch, I should get a different measurement than if I open the load switch. And if I take my ammeter, connect my ammeter to A and B with the load switch open, my ammeter connected to A and B, I should be able to measure the current that the battery will produce. And this is my table. I've got electrolyte salt water and distilled water. Measure the specific gravity of salt water and this distilled water. Measure the voltages of each cell. Measure the individual voltage of each cell. Measure the open circuit, meaning load switch is open. Measure the voltage of the open circuit for distilled water and salt water. And measure the closed circuit, meaning I close the load switch. I should get a different voltage reading, should be lower than the voltage, the open circuit voltage. And then I'll subtract the two, come up with a delta V, open circuit minus closed circuit, come up with a delta V for each salt water and distilled water. Then measure the current that it's producing in each condition. And go using this formula, should come up with an internal resistance. This is basically Ohm's law, really. Should come up with internal resistance for the battery. Let's go ahead and move to the next slide. And this is how we can connect our ammeter, connect our voltmeter, and individual cells can be done over here. And with the battery switch closed, my voltmeter should read the total voltage. And with my load switch closed, my voltmeter should read a slightly lower voltage. And with my ammeter, my battery switch should be closed again. My load switch will be open, and that would force the current to go through the ammeter and give me my current. And these are the measurements that we did in class, Eric and I did in class to see how the system's working. We got 1.030 and 0.73 basically across the board. A battery of open circuit voltage of 2.98, and it went down to 2.55 when we did the closed circuit. Our delta V, but it's not 2.98 minus 2.55, came up to 0.43, and our current was 70 microamps. Doing the math, it came up to about 6,000 kiloohms. The distilled water was 1.00, 0.79, 0.79, 0.79 across the board, 3.2 for open circuit voltage. It went down to 2.48 for our closed circuit voltage. Our delta V went up to about 0.72, and our current load went down to about 18 microamps. And our internal resistance went up to about 40,000 ohms. That was our experiment. Now let's see how the students did. This was me in the classroom giving a demonstration on how to measure the specific gravity of sulfuric acid using PPE to be safe and using a container so I didn't have to worry about any spills. Any spills would be contained inside the container. And when I measured, it came out to about 1.27 on the specific gravity of the sulfuric acid. Moving to the next slide. I'm measuring the specific gravity of a dead cell, and it's way up here in the red. And I'm measuring the specific gravity of sulfuric acid, and it's way here in the green. Giving the students a demonstration in the classroom of how to be safe and how to measure specific gravity of a battery. And this is a student, he's actually measuring the specific gravity of salt water right now. And at that level, it's right around 1.030. And that's for salt water. This is the distilled water battery version. At that level there, he's measuring at about 1.00 distilled water. Moving on, he's measuring the off-load voltage of the salt water battery and the on-load voltage of the salt water battery. So the load switch is off, the LED is off. He is connected to A and G. He's measuring 3.109. He's turned the load switch on. The LED is actually illuminated, measuring A and G, and our voltage went down to 2.538 for our salt water battery. And doing the same thing for the distilled water, our initial voltage started out at 3.33 with distilled water A to G, and our load voltage was down to 2.4, and you can see the LED is actually on, illuminated, and he's measuring across A and G again. And in this case, he's connected to A and B. He's measuring 6.0 microamps. If you can see, it is just barely on. The LED is barely on. And in this case, this is the saltwater version, measuring A and B again. The LED is actually illuminated, and it's measuring about 0.08 milliamps in this case. So 6 microamps, 0.08 milliamps. And this was his table that he submitted. In addition to what we had earlier, I added a corrosion level and damage level. They have to inspect the battery, inspect the cells for corrosion, and inspect the cells for damage. Again, he measured at 1.030 and 1.0, 79, 79, 78, 78 across the board up there. And distilled water, our cell voltage went up a little bit to 0.8, 0.8, 0.8. Our battery open circuit voltage was 3.109. Closed circuit voltage is 2.58 or 538. And for the distilled water went up to 3.3 and 2.4. Our delta V for the salt water was 0.57. Delta V for the distilled water was 0.91. And our current for the salt water was 0.08 milli. And for the distilled water went down to 6 microamps. If you did the math, it comes out to about 7,000 ohms for the saltwater battery and about 151,000 ohms for the distilled water battery. So yeah, it worked out pretty good. And this is just another student measuring the specific gravity of distilled water, and here he's measuring specific gravity of salt water. And overall, this is how all the different batteries performed. This is all 6 batteries. The open circuit voltage for all 6 batteries was right around the 3 point something. This one, I don't know why this one's so much lower, but it could be differences in the meters that the students used. And the open circuit for the distilled water went much higher, 3.3, 3.5. It went up from that side, from the salt water. The closed circuit salt water was 2.5, and this was pretty consistent across the board. The closed circuit for the distilled water was also pretty consistent across the board. And we come down here to the delta V, the change in voltage between load current and no load current. The salt water was down in this range, pretty close to consistent. The distilled water was up higher in this range. So that's an indication right there that we have a internal resistance on our battery. And our load current with the saltwater battery was actually putting out some current. And if you see the current for the distilled water, it's barely on the graph. All the distilled water currents were very, very low. So pretty consistent across the board on everything. And this is also consistent with a sulfuric acid battery, by the way. And break it down a little bit differently. The open circuit voltage for salt water versus the open circuit voltage for distilled water. The salt water is in blue, distilled water is in orange, and the battery voltage went up between the two for the open circuit versions. That was consistent on everything. And go to the next one. The closed circuit saltwater battery, closed circuit distilled water battery. Again, the saltwater battery was much higher, consistently across the board. The numbers a little bit differently. I'm pretty sure that that was because the individual voltmeters that the students were using created that situation. And moving on to the Delta Vs, the saltwater batteries are all in blue still, and the distilled water batteries are all much higher in orange. And the load current, you can see that the load current for the saltwater batteries was much higher than the load current for the distilled water. Distilled water cannot put out that much voltage. So all of this is consistent with a sulfuric acid battery. And when the internal resistance went up. Saltwater battery internal resistance is fairly low. Distilled water battery resistance is fairly high. So, and in conclusion, this is each individual battery and the saltwater version, OCOC, VC, all of the measurements that we took. So, I want to just say thank you, Eric. You did a good job. It seemed to work out pretty good. The numbers are pretty consistent. I would like to see if I can make it a little bit more consistent, but for what we've got now, it seems to be pretty good. And the students have to actually measure specific gravities and determine the internal resistance of the batteries, and it seems to be working pretty good. Hope you like it. Hope the FAA approves of it. Okay, see you later. Thank you.